Do you not think they're smiling at us? You got to be kidding me.
No.
All righty, welcome, guys, to the next segment of Chapter 2, Lesson 1. We're going to finish this up real quick. We're going to review, and then we're going to press on to Lesson 2 and finish that up here today. All right, open up our books to page 126. I know since you guys studied this stuff so diligently here lately, and let me get to we passed all the different parts of our atmospheres, but we're to the actual meat and potatoes as how the atmosphere affects our flight. So I actually have been lying to you guys. Did you all know that? Oh, bad Colonel Peoples. Not by intention, but I certainly did lie to you and say a wrong word or two. All righty, page 126, we talk about the density of our atmosphere and how it affects our flight. The bottom line is that the lower altitudes, meaning closer to sea level, has higher density than higher altitudes like where we are right now with your feet here in Prescott, 6,000 feet. So what this means at higher altitudes with less dense, turboprops and engines, and oh, by the way, cars, except cars are kind of advanced now, have less oxygen and you're less efficient and you take in less air because you're at higher altitude. My wife Susie and I actually own property in Colorado at a town called Creede, Colorado, 9,800 feet. Do you think it takes longer for an airplane to take off at 9,800 feet versus Phoenix, Arizona, which is 1,700?
Yes, sir.
It's huge. I'm not going to go through that in this class, but in my advanced class where I talk about teaching you guys how to fly with Jefferson, we actually go through the takeoff and landing data and the taking off of the same plane at 9,800 feet in Creede, Colorado versus Phoenix, Arizona. It's huge. It's like 4,000 more feet for a Cessna to take off. And so you got to worry about that, takeoff and landing data. Pressure. Pressure, altitude, same thing. In general, remember, wind is the unequal heating of the Earth's surface. In general, pressure, you go from high pressure to low pressure. Okay, this is our fronts that go around the world. Increasing your altitude affects your atmospheric pressure. It actually says here on the slide, atmospheric weight at 18,000 feet is half of what it is at sea level. That affects all the motions of the wind and all the fronts that go around the world. Scuba diving. I do scuba diving last weekend with my son Ryan down in Lake Pleasant. So you're diving in Lake Pleasant below the water. It's higher pressure. That affects your body, and it's detailed, but it affects the nitrogen in your body. You can come out of it. We had to worry about diving deep on Lake Pleasant and then driving up to Prescott because you are decreasing your pressure from 1,700 feet to 6,000 feet. We had to wait 2.5 hours to have our bodies equalize at 1,700 feet before we drive up here. Because in scuba diving, you're not supposed to fly for 12 hours after scuba diving. Because you would be going up to a pressure, altitude of 8,000 feet, and you're underwater at higher pressure, and you go up to 8,000 feet at less pressure, your body can get messed up. It's details, but you have nitrogen narcosis is what the term is. So we have to worry about this stuff. When you fly in a pressurized plane at 30 to 40,000 feet, you're not at 30 to 40,000 feet altitude pressure. You're basically at 8,000. That's the general number that you are. Okay? Less pressure, less oxygen, and it does affect your body. Here is where I misled you. Should I say the word lie? Honest, I really did lie to you unintentionally. How much did I tell you the altitude difference for the temperature difference for every 1,000 foot was?
2.5.
That is a lie. Okay, don't believe me. I lied. It's actually 3.5 degrees. And if you look on page 129, it says the temperature drops at the rate of 3.5 degrees Fahrenheit or 2 degrees centigrade for every 1,000-foot gain. And that is what this chart depicts. And basically, I misspoke. I did not mean to, but I got the 2 degrees centigrade and the 3.5 degrees Fahrenheit mixed up in my mind, and I made a mistake. So when we are about 4,000 feet above Phoenix, how much is the temperature in a perfect world? What's the difference in temperature? 4 times 3.5 is 4 times 3.5 is 12, 14 or so, 14 degrees. And if you look at it, almost every day, we're about 10 to 15 degrees cooler than Phoenix. That's why everybody likes Prescott. Same thing for Flagstaff, which is higher than us. Is it colder in Flag than in here? Yes. Yeah, it's always colder. And a lot of it has to do with the difference in altitude. Yes, sir?
It's 17 degrees, sir.
What is 17 degrees? 3.5 times 4.
Okay, guys, hello, time out. Don't worry about it. Just big picture, okay? Read the chart that I have here, okay? All right, so that is the difference. And so look at the bottom there. If you're flying up at 20,000 feet, that's pretty chilly willy up there. It's below zero, way below zero. What happens if you eject at 20,000 feet? You have to jump out of the plane.
You get cold, sir.
You get cold. What about if you're in World War II and you're flying in these unpressurized planes and they're flying over the Himalayas at 30,000 feet? Is that chilly willy? They wear gloves, they wear insulated, they actually had heated underwear, believe it or not. They had you plug in your underwear to the plane, it heats you up.
Oh my.
But look at the numbers. At negative 30 degrees Fahrenheit, that's called going to war. It's not like old Hollywood looking great. It's pretty miserable conditions. It is pretty miserable conditions. So anyway, that's normal. That is absolutely normal. Okay, that is the end of lesson 1. Let's change around and turn to lesson 2, page 132. We've talked about the big picture in atmosphere, and now we're going to talk about the weather elements. Let's look at your vocabulary there. Let's see, I can pull this up. On the right side, that is important for this lesson. Transcontinental, what does that mean?
Across the
There you go, love it. Transatlantic.
Across the Atlantic.
Transpacific.
Across the Pacific. Arctic.
Prescott High School.
Across Bradshaw. Across Bradshaw.
Okay, actually, we talked about some of this stuff. Wind shifts, what does that mean?
When there's shifts in the winds where it'll go from having headwind to like tailwind.
We just talked about an accident in New Orleans that happened. Yes, you're exactly like a change. A shift is a change. Ooh, this is a different question. What is squall?
Squall's a bird.
A bird. Actually, a squall. A squall line. What would that be? What would a squall line be? Well, we'll learn that. Ooh, occluded front. That's a good word.
I know what a squall line is.
Okay, what is a squall line?
A squall line is a narrow band of active thunderstorms.
A narrow band of active thunderstorms. Squall lines are bad. We want to stay away. We have that picture of the one big thunderstorm. Imagine that times 15. That's bad. Squall lines are bad. Occluded front.
Boundary area that forms when a fast-moving cold front catches up with a slow-moving warm front.
Very good point. Occluded front has good weather or bad weather?
Bad weather.
Bad weather. Occluded fronts are bummers. They hang around for days. Okay, so they have bad weather and they hang around for days. And also on this line of vocabulary here, I want my Arizona kids who grew up a mile above the ocean to know what windward is and leeward is. What's windward?
Windward is the side facing the wind.
Yay. Okay, like when we're talking about sailboat. Okay, what is Leeward is not pronounced leeward, it's pronounced leeward.
The opposite.
So what is leeward?
Side facing away from
It's downwind. Yes, very good, very good. I like that. I like that you guys know that. That's cool. Okay, thank you very much. All right, we need to actually today get our CPSs. So why don't we everybody go grab the CPSs while I set this up?
3 and 38. Talk, give me 45.
Get 43 and 38, please.
Hey, what is your number? No, keep
Todd trying to take my number 49.
Todd needs to tie my shoe again.
Do you like my costume?
It's like 53 now, 49.
Isn't it the
No,
same
it's an old
thing?
shoe.
Arctic front and polar front? I mean, they're both cold winds.
It's very cold winds. You're exactly right. Okay, guys, look at the picture here on the bottom of page 135. I got it on the overhead. These are the big things that we're going to go here for this next few minutes is talking about air masses and fronts. Okay? We learned about what causes winds, but these air masses and fronts are sort of the results of the wind. It's sort of the chicken and the eggs. The masses cause the winds cause the masses. These are huge areas that float across the globe and basically drive our weather. We have different ways of determining them, whether or not they're the pressure, the barometric pressure that we just talked about that decreases with altitude, also decreases with the weather. In general, low pressure is bad, high pressure is good. So if you have a high pressure system, you're going to have good weather. You're going to have those cirrus clouds. You're going to have the angel hair that we talk at high level. If you have low pressure, you're going to have bad weather. You look on the maps that now we have on the internet. These are the maps that show the different pressure systems going through. This picture I have actually shows basically the way that they're annotated on the charts. Oh, does that not look good? Does that not come through? That is weird. Why in the world did it do that? That is not good. Weather refers to the air masses. Oh, let's see here. That doesn't make sense. Let's try that again. It only happened when I'm trying to do it here and crank through it. Got your scanners. Okay, let's see if it'll get centered this time. Okay, there we go. Air masses, large body of air moving through. In general, let me ask a question. Cold fronts are good weather or warm fronts are good weather?
Warm fronts.
Yay! And warm fronts generally have high pressure because warm air increases the pressure. Cold fronts are in general bad weather with low pressure. And so think about it, just like the picture we have there, the cold air masses come down from the polar or the Arctic, and in general that cold air hitting warm air creates bad weather. This doesn't happen much in Arizona, okay? In general, it does, but we don't notice the effects of horrible weather. Matter of fact, last night, did anybody see the TV last night?
No, it's trick-or-treating.
It was cold.
Yeah.
8 inches of rain in Indiana, Illinois. They canceled Halloween last night because the weather was so bad. 8 inches, 9 inches of rain in 6 hours. Okay?
What happened?
A cold front hit a warm front, and they had miserable weather.
What happens when they cancel a holiday?
What they generally do is they cancel it, and then the local mayor will say, okay, we'll celebrate on Saturday. Because oh, by the way, these fronts generally move fast. I mean, in one day, they're gone through. Okay, here in Arizona, it may come and it may snow for a day or two, because the fronts don't move that fast here, but in general, the other places are coming through. Here, you can see here, on the picture, you have warm front, cold front, stationary front, occluded front. Stationary and occluded do not move very fast. Warm fronts, good weather, generally move slower than cold fronts. Cadet Smith, you okay?
Yeah.
Yeah?
Yes, sir.
Okay. So, in this, the different fronts on page 138, it is important that you know the different types of wind patterns with the different types of fronts. And actually, there are some good pictures here. In general, when we're talking about weather for high pressure systems, and they have the big H here, so the barometric pressure is going up, which way does the wind blow?
Left.
Left. It blows left or right. Okay.
From the west.
Counterclockwise or clockwise? What do you think?
Left.
Picture's right there. Highs go clockwise. Okay.
Oh, yeah, you're right.
Oh yeah, you're right. So here is America, and here is the Baja, and here is Phoenix, Arizona. Okay, AZ. And if we have a huge high pressure system coming into California, and the weather is clockwise around this, the winds will be coming from the northeast. That makes sense. Depends on where it is. If it is a low pressure system,
Coming from the southwest.
yes, if we have, let's change this around and put a big L here. How does the wind blow for a low pressure system? It's a well, no, it depends on where the pressure is, but it's a counterclockwise flow. Okay? So a low pressure system, if this is the Baja here, and then we have a hurricane coming up through here, you're going to have rain and wind. It just happened actually about a month ago. A low pressure system comes in, and you're going to have a southerly flow of wind into Arizona. Remember, in general, everything is going from the west to the east, so it will come this way. And you can see this on the Weather Channel every day. But you remember, high is clockwise, low is counterclockwise. And actually, that is why when we're dealing with the eastern part of America, where we actually get, this is the eastern part of America, okay, this is Florida, this is the Gulf. We have hurricanes that show up. Are hurricanes high or low pressure systems?
Low pressure.
They are low pressure systems, and so therefore if they're low pressure systems, which way do the winds blow?
Counterclockwise.
They blow counterclockwise. And so do they come from the west or they come from the east?
The east.
They come from the east along the equator, right? We said the northern hemisphere of the weather comes from the west. So the lows come this way. And if they're blowing counterclockwise, opposite the clock, these hurricanes are like this. Okay? And let's say they hit Miami, which a huge one hit Miami. Okay? It really matters where the eye of the hurricane hits. If the eye of the hurricane hits right at your town, your area, that does stink. That is bad. But where is the most damage for the water? So if your actual hurricane hits right here on the eye, is your most damage with the water surge north or south of the eye?
North.
Think about the flow. You're blowing a huge amount of water this way, so yeah, the huge surge will be north of the eye. The south of the eye is bad, but it's not that bad because the wind is coming from the, it's counterclockwise. The wind's coming this way. And that's why people worry about hurricanes on the East Coast so much, depending on where the actual eye hits. The eye can hit 10 miles north of you, and it's no big deal. the eye hits where you are, they'll have the highest winds, but the huge surge, which floods and wipes you out, is north of the eye all the time. That's very important.
Really calm.
In the center of the eye, it's absolutely calm. You look up and see blue sky, and I've had buddies that have actually done it. That's not just a rumor. It's a we'll talk about it later, but I actually have a lot of knowledge about this huge hurricane called Hugo, which hit Charleston, South Carolina, where I'm from, or my family, and I've had my family go through it. But yeah, if the eye passes over your house, you can look up and see blue sky, and then all of a sudden, in 15 minutes, you'll have 200-mile-an-hour winds wiping out your house. In the opposite direction, okay? So the eye comes through, and it blows one way, and then you see blue sky, and you're, wow, that's really cool. Let's go jump back in. And there were people that did that in Charleston, South Carolina, where I was from, in a hotel. They jumped outside. They saw blue skies. They took pictures. And they looked, my goodness, that looks like a wall of 200-mile-an-hour winds. And they jumped back in and got wiped out. Oh. So yes, that happens. That happens.
That's why they keep running with it.
Exactly. They keep running with it. Okay, let's finish up this big picture here about the messes in the wind. When we're talking about the winds blowing, you need to look on page 140, 141. Air always seeks out lower pressure. So lower pressure, just like I have here on the overhead, will help the movement of these masses. The wind always goes, the masses always go from higher pressure to lower pressure, enforcing the fronts around. How does this all affect us flying? That's what we really care about in this flying course. On page 141, and let me zoom that back down. Come on, baby. There we go. If you're flying into a warm front, you can see how a warm front overcomes a cold front in the display here. And on page 141, stratiform, and we were talking about stratus clouds yesterday. Cadet Todd, why don't you please stand at attention over there. The stratus means layers of clouds, okay? So when you have warm air coming over cold air, you're going to have problems with your visual flight rules. You can have a lot of weather, and you can see how it literally comes over you, and we know this by measuring the temperature. You have temperature, you have weather balloons that go up, and the people check the weather balloons like it. Likewise, over here on page 143, a cold front coming into a warm front, that is the worst type. A cold front coming into a warm front produces not just stratus clouds, but it really produces the huge thunderstorms, the cumulonimbus, the worst weather. And these are the huge fronts that affect us mainly in the summer because we have warm air, but you may have a cold front come through with warm air, and then that condenses the air, has uplift, and gives us the huge bad weather. This is definitely not visual flight rules. You definitely have horrible weather, and you're flying with instruments the entire time through the clouds. Visibility is very low, and basically you shut down airports. You don't land these big planes in the middle of thunderstorms. Used to be you did, but then they had some deaths, and they shut that down. Surprise, surprise. Here up at the top, page 145 on the top. Warm air on top of cold air provides an occluded front. Like I said, there's not much movement there. You have heavy precipitation, poor visibility, falling barometric pressure. Even when it moves, you have nimbostratus and cumulonimbus, the worst type of clouds around. And that is, again, bad visibility. Okay? And so those are the problems that work out and then help out the weather to create poor visibility and bad flying opportunities. Page 146. This is a neat picture for me. This does not exist on the East Coast, really, where you have Moist air on top of page 146 coming across the Pacific Ocean. This is Monterey, California. That's a beautiful area. But basically look at the lift, the oceanographic lift of the moist air. So the moist air creates a fog, and I guess fog is basically a cloud at sea level, okay? And so you can see, yeah, it's a cloud, but it's actually at sea level, so it's a fog. And that type of effect gives you a lot of different bad weather also that you have to worry about. Look at the picture on page 147. Okay? This is actually something that happens on the East Coast, mainly New York. We have these beautiful lakes, the Finger Lakes of New York. When you have cold air coming from Canada across a weathered area like a lake, heat and moisture, and you have a huge amount of snow. Matter of fact, Colonel DeKemper's daughter now lives in, I believe it's New Hampshire, and she has to worry about lake effect snow with, we're not talking 6 inches, we're talking 3 feet in a night. 3 feet of snow in a night because of this exact example here on your lesson. So you can actually see that your effect of the terrain and the cold and warm front can exasperate to make your actual weather a lot worse than ever before. And I think that is the end of it. Why don't we go through the questions? Get your clickers ready here. Your clickers ready? Let me see if I can get to the source here. And get ready to click. Yes, sir. You go for it. That's a good point.
Can we,
Curdo, that's not working.
And we can't click.
It's not working?
The signal is interrupted. The remotes won't respond.
Bad Colonel Peoples. Why did that happen?
I told you it was boundary.
You told me it was the boundary layer. Why in the world? And let's see here. Do I have MS-200 here? I have vocabulary.
Maybe the spaceship's not on.
Lesson. Maybe the spaceship is my space. That's a good point. Here's a spaceship. Let's see if that works. Let's see if that works.
Need some more juice. Space juice.
Could be hard.
These are the same questions that'll be on your test guide, which you love so much. I did great on the test the other day.
You guys said we
It says scanning for the receivers. You hold up your Huh. Can I take a picture of this? Oh, you broke it. You broke it.
Didn't bring it.
You know what?
Stand at attention on his hand.
That's $500 right
I am having technical difficulties. This worked just the other day. What did you mess with my
yeah, Cody.
Cody?
Yeah.
Which one?
Van Boeven.
I didn't touch it.
He can't reach that without someone to boost him up.
I love it. I love it.
It's
So are
10
you up
after
again?
10. Yeah, 10 after 10.
Okay.
It's
All right.
5 after.
That's the only way to use it now.
Unable to communicate. You guys broke it. Okay. Well, we will stop this class here and we'll go to lesson 3 the next time.